So our next speaker is Jason McFall from Privitar, who's going to talk to us about privacy risks and solutions in financial services and telco.
Hello everybody, thank you for having me. So I'm CTO at Privitar. Privitar is a London-based software company startup. We build enterprise software to allow large organizations to analyze data safely and manage privacy risks. And we don't work, we do a lot of work with financial services and telco, not exclusively, but a lot. So I've been asked to talk a little bit about the state of the nation in these two industries. So the first thing to talk about is the environment. The big thing that's happened over the last few years is the proliferation of Hadoop. So Hadoop, for anybody who doesn't know, is a parallel data processing technology which came out of the internet giants, Google, Yahoo, and others, and essentially makes it very easy to store, first of all, and then to analyze vast quantities of data. And it's now penetrated the financial services organizations, banks, insurance companies, and also telcos. They started off just experimenting with it. Now there's a huge demand for data scientists to do work with this data, and they're moving into production use cases. And Hadoop and big data in general, they change the game. The first thing is disk is cheap, so you really can store all the data. You genuinely can. And I think there was a phase initially of just throw the data in, it might be useful later, don't worry about what you're storing. That's changing somewhat, fortunately, thanks to things like GDPR. But there was that nature. And one of the consequences of that is it's hard to keep track of what private data is stored. Another reason for that is that Hadoop is essentially schemaless. So whereas in many traditional enterprises, and they still have these, they might have tens of thousands of databases, at least those databases have schemas that somebody has to manage somewhere. In a Hadoop cluster, you can just throw the data in, which makes it a lot harder to keep track of what data is stored. It also makes it harder to keep track of the potential linkage risks between those data sets. Many organizations are building out what are called multi-tenant clusters, where one part of the business might use it for one purpose, another part of the business might use it for another purpose. They might completely, in ignorance of each other, put in two data sets which could themselves be joined and linked. And so there are all kinds of linkage risk. And then, of course, parallel computation lets you find patterns in these data sets, huge patterns. And just think about the sensitive patterns that can be found in all of our location data, our phone data, our financial transactions. So there are lots of new risks that come from this technology. But there are also huge opportunities. And so I've tried to classify these for financial services, and by that I mean payment processors, banks, insurance companies, markets and exchanges, and telecoms. And there are essentially two classes. One is doing a better job of what they do today, so improved operations, and things like fraud prevention are very big here. So being able to mine through data and understand the patterns and behaviors that are fraudulent and distill out those patterns and differentiate from good behavior is important in financial services, also in telco actually. And in fact, there are interesting ways in which the two can collaborate. So there are payment providers taking account of whether your mobile phone is co-located with your card when you use a card abroad, which I think is a very nice idea. Banks can do better risk calculations, can combat financial crime. Telcos can do network optimization, can better understand their customers. And then there's a whole class of business growth, let's call it, so new things that these organizations can do with the data that they have. Developing analytics products, benchmarking products. We've just seen one great example of a good use of location data. And there are even things like understanding spread of diseases using mobile phone location data. And Internet of Things is going to be a huge emerging space, new products and new data, with also new data risks. Now the good news for all of us as consumers, I think, certainly our experience has been that enterprises are very, very responsible. They don't play fast and loose with data. Now there might be some selection bias here in that it's only the ones that we talk to that are highly responsible, and that's why they're talking to us, but I don't think so. I think they are very highly responsible, very cautious about what they want to do with sensitive data. But what that means is that innovation is being stifled, and I think we'd probably all agree that many of the things on the previous slide are of huge value to society. They're of economic value, but there are lots of societal benefits from these things as well. And banks and telcos, they're struggling with a number of things. They're struggling to share their own data with data science teams and research teams within their own organizations. They're afraid to do so. They're afraid of the risk of giving out that data. With every new person that you give access to data, there's a risk of that person doing something uncontrolled or being bribed or making a mistake. So they're afraid of doing that. They want to collaborate with academics, with fintechs, with new startups. Invariably, that means sharing data. How do they go about that safely? Ironically, we encounter this ourselves. When we go into a new organization and we want to explain how we can help them anonymize their data, almost the first thing that happens is they go, well, we can't give you our data to anonymize. So there's sort of a bootstrap getting started problem. We can help solve that, and we can help solve that for them to use data with other organizations. One thing which it sounds simple, but it's really important, is how do they use real data for development and production and test of their systems? These organizations have very strict rules that they don't just give out production data to the dev and test teams. But for things like smart statistical models that are looking for fraud patterns or looking for anomalies, you just can't do it with synthetic data. There's no way. So how do you solve this problem? These are real problems that people are struggling with. And then finally, building data products. So on the bottom of the previous slide, there are lots and lots of valuable things one can do with data, and we've seen a great example. How can you guarantee no privacy leakage, or maybe guarantee is too strong a term? How can you provide bounded risk on any leakage of sensitive information? So this is the challenge. And the current state of the art, honestly, is pretty rudimentary. So organizations are putting in place access controls, and by that I mean physical access controls to the data as well as good processes. They're using data minimization, and by that I mean no longer throwing everything into their cluster, but being more controlled and having a clear business justification for why data is stored and used. And then they're applying de-identification, pseudonymization, as we just heard. I call it tokenization, so basically replacing any identifier with a randomly generated token. They're doing that on ingest into their clusters. And then the sort of next frontier, which some organizations are doing, is aggregating or k-anonymizing that data, which really works well for what I call rectangular data, where there's one row per data subject. But most data isn't like that, of course. If you think about your history of transactions, if you think about flows of people through time and space, most data isn't clean and rectangular, so there's a big challenge there. So what is the leading edge, and where do people need help? The first, I think, is people need to monitor and control and better understand the sensitive data in their cluster. There are lots of ways of doing k-anonymization more intelligently. So even something as simple as aggregating data, you can do it in ways that maximize the utility for a particular purpose. Controlled interfaces of data, we believe that not giving people access to the raw data, but giving them a controlled interface to the data is one means, and Christine talked about some of the advantages and disadvantages of that. And again, differentially private analytics, again, offers great possibilities, but also some of the limitations of getting to the raw data. And then some of the data that people are dealing with is just not straightforward. So time series data, transaction series data, streams of locations, it's messy, it's hard, and there aren't good, well-established techniques for this. So let me give you just a flavor of why this is hard. Let's talk about location data. So as you move around with your phone, points in space, your points in space and time is recorded. And for example, just adding a bit of noise to that data point is useless, okay? Because if you have a stream of data, then it's very easy to fit to that trajectory. And if you have repeated observations for somebody, then it's very easy to smooth out that noise and understand, for example, where somebody lives, where they work, where they spend time. So there's a lot you can learn from trajectories. And anybody who's seen the fiasco of the New York taxi data set, there are all kinds of, apart from the fact that it wasn't anonymized at all well, there are all kinds of remarkably creative ways that people can de-anonymize this data. Here there was a case where somebody took photos of celebrities getting in and out of cabs in New York from blogs and matched them against timestamps and the identities of the cabs, and then matched them to the journeys. We've done quite a lot of research around this area, so let me just give you a flavor of why this is hard. This is just a map of London with some location points imposed, and one thing you could think of doing is a k-anonymity style approach where you tile the space and you say, okay, I'm going to carve the space into regions and have a minimum number of people in each region. Now that's maybe okay, averaging out the space, that gives you some protection on where were people. Once you have many observations, as I say, you can start to smooth these things out. But what about things like sensitive attribute disclosure? So I don't know if you can see well, but on here I've also drawn some orange dots. I don't know how to go back. Some orange dots. So let's say the blue dots are the locations of people, and the orange dots are places of interest. Now, if those places of interest are hospitals, places of worship, maybe gay nightclubs, whatever it might be, then there's huge privacy and confidentiality questions around just understanding where people are. So now you need to apply an L-diversity type approach to have a diversity of locations of interest within a cell. And so your big data privacy problem becomes a big data problem in how to treat this data, because the locations aren't in this data set. So it's very much, it comes back to the question that's been raised several times about context in which data is used. You have to take the context and the existence of external data sources into consideration, and it becomes a big data problem to anonymize this data. So in the absence of good techniques around time series data, location data, we think the recommended process is this, which funnily enough looks pretty much exactly like Brendan's diagram, which is read in the data, de-identify it by stripping off identifiers, and then compute the features that you're going to use for your analysis, get those into a shape that you can apply good, well-established techniques, and produce anonymized feature vectors that you can then share or provide access to. And the problem with this is it's not powerful enough. So you could do this through having a controlled access interface, but as Christine talked about, data scientists, they need access to the raw data. What if the data's noisy? What if it's bad? And so the challenge is, how do we collapse down this box? How do we develop better techniques to understand this? So just to conclude, Big Data and Hadoop, they bring new privacy risks, but I think many of these are addressable through technology, just as they're raised by technology. There's huge opportunity for innovation, which would benefit all of us if this data could be used safely. And the innovation is bounded by privacy concerns, which I think is the right way around. And what we want to do, certainly as an organization, is find ways to unlock more innovation. There are good practices which have emerged, I think, for more structured data, but everything else is much, much harder and is done on a bespoke basis. And I think for this forum, this is where there's a real need for industry and academic collaboration to find better techniques to manage this data. And of course, context is all important, as people have said over and over again.
Okay, so our next speaker is Paul Abreu, who's going to talk to us about the GPE energy networks and smart meter program and using the network operators to use that data.
Thanks very much, Mark, and I'm pleased to be here and just give you an insight into a data access challenge that our members, the electricity network operators, have. I work for Energy Networks Association, and our association represents all the gas and electricity transmission and distribution companies in Great Britain and Ireland. And an important distinction to make here is that our members are not the suppliers that send you the bill for your gas or electricity. We are the network operators. Our members own the infrastructure that delivers that energy to your home. So in today's short presentation, I'll give you a quick overview of the smart meter program and the functionality and data that's available from the smart metering system to our members, and we'll specifically look at half-hourly electricity consumption data, as that is a specific item of data that needs anonymisation, and then we'll look at restrictions on access to that data because of it being personal, and what DNOs are doing to try and get hold of that information to deliver benefits to their customers. So the smart meter program is a mandated program, and suppliers have the obligation to deliver 53 million meter replacements before 2020. The mass rollout of those replacements, every gas and electricity meter in your home will be replaced by 2020. The mass rollout starts next year, and consumers will be able, once they have these smart meters, will be able to look in near enough real time at their consumption, and they'll be able to share that consumption detail with approved third parties like switching sites and try and get the best tariffs for themselves. This is very much part of a much larger project to provide smart grid across GB and to enable that transition to a low carbon future. Network operators don't install the meters, but they are legitimate users of the DCC system that will enable connectivity to those meters and the data it contains. It's important to say that the data in this system only exists in every meter that's in the meter that's in your home and nowhere else. The DCC, the data communication company, provides the infrastructure to get at that data. It's just a tube, it's just a communications channel for the approved users of the system to access the data contained in the meter in your home. There's a number of things like alerts that network operators will receive and lots of information stored in the meter that network operators can access. One of those items, the item in red that I've shown here in this slide, has been categorised as personal information and is subject to much more stringent privacy controls, and that's the one we're going to be talking about now today. The others, there's the usual controls, but not so stringent because it's not warranted as personal data. So a typical half-hourly profile stored in the electricity meter looks like this, and this is a 48 plot over your normal day, and these are 13 months, rolling 13 months worth of daily data that's stored in the meter, and you can start to work out what the consumer behaviours are by looking at that half-hourly profile. So why do electricity network operators want access to this data? Traditionally, energy has flowed one way in their networks. Things are starting to change. They're very much more challenging sort of dynamics within the electricity distribution network. Network operators are incentivized to run the most efficient and economic network possible to keep network costs as low as possible for consumers, and they're incentivized by the regulator to do that. But in this changing smart environment, the flows with more localized generation are starting to show different behaviors, and it's important for networks to be ahead of the game and enable the network to be ready for consumers to take their smart choices and to have energy, and interact with energy in different ways than they've always done. So it's really important to get access to that data. So there's no physical barrier in the smart metering system to stop a network operator accessing this half-hourly data. There's only a legislation. The barriers only exist in legislation, in their license conditions, and obviously the contents of the Data Protection Act as well. So, but accessing half-hourly consumption data with the data that they extract comes the meter point administration number and the device ID reference number. And with either of those items and other data sets, they can identify the customer. So that's why this is a particularly sensitive area. So where are the legislation barriers for networks in this regard? And that is very much in their distribution license, and none of the network operators want to be in breach of license, so they make absolutely certain that's one of the things they most focus their attention on, is being license compliant. There is a license prohibition on them obtaining this half-hourly consumption data. There are 3 ways that they can obtain it currently in the license, and that is that they can get the explicit consent from each customer, and they have to sort of write the customer and ask that individually, and that's not really that practical for them because customers move house, and it's keeping that is really not practical to keep that managed. That if they suspect illegal abstraction of electricity or theft, they can access that data, or if they want to have a study or a network trial, they can ask the customers and give them 14 days notice, and if the customer doesn't object, they can access that half-hourly consumption data. So the SLC 10A, this license condition, exists, as well as they're also required to comply with the Data Protection Act. So there are, in the license, there's exceptions to this prohibition, and that is that the network operator has to submit a data access and privacy framework to the regulator, Ofgem, and it's very important that in the words of that, I put the words there in red, the words within that prohibition exception in the license actually requires that the network operator through its aggregation with other electricity consumption data, anonymizes that information, and we've sort of met with Mark to talk about this challenge and how that might happen. And we're not going into solution mode in my talk like we did with the previous talks. It's really a challenge for network operators to approach that, how they anonymize. But also those frameworks need to give specific details on how that anonymization has occurred, and also describe the benefits that goes to consumers from use of that anonymized data, and how they're going to make that a secure environment. So we've looked at anonymizing through aggregation, as that's specifically mentioned in the license condition, and we've looked at aggregation, and the problem with aggregation is that the more you aggregate consumption profiles, the less useful it becomes to network operators, and it's a real issue for them. Particularly when you've got rural networks with very few customers, you start to get big blind spots if you aggregate at very high levels. And in networks where you've got very few smart meters, it's the same challenge. So aggregation is really doesn't seem to be such a solution for networks. It end up with lots of parts of their networks that they can't get that visibility, that granularity that they need. None of them have put forward a framework yet for approval by the regulator, but we're not sure until one of the companies produces that framework for approval and suggests an aggregation level of 3, whether the regulator will say yes, that's sufficient to warrant it as sort of anonymised, and we think perhaps not. And certainly the ICO perspective, aggregating to a level of 2 or 3 it still means that the data is personal and subject to the DPA. So the license also mentions anonymisation by means of any other process. So they're looking at how else they can anonymise that half-hourly consumption data, and one of the ways is to store the raw data in a secure environment with restricted controlled access, and the other is to sort of store that data separately from the identifiers, the MPAN and the device ID. But whatever way they do it, they still need to reference that each half-hourly profile to a point on their network, because that's what gives them the information they need on how big the cable needs to be and what bits of the network need reinforcing, and to sort of make sure there's no power cuts and disruption in supplies and reliability to consumers connected to that network. So they're looking at how they can be compliant with SLC 10A, and this is the only way they can currently see that they can be compliant, is to anonymise at the point of collection. So when they make the correct request to a number of meters, they will pull in that sort of and aggregate those values to a minimum amount, an acceptable amount of aggregation that sort of is accepted, and that no one's given them a number. The Ofgem hasn't said it's 10 or 9 or 11. The networks need to sort of make that argument in their privacy framework and say this is a sufficient level of aggregation to warrant it anonymised, but it's likely it's going to be a higher number, and that gives you that issue on rural areas and areas with very few number of smart meters, and they lose that visibility across a large part of their network. So this is not a great solution and a great option for networks but it's probably the one that will comply with the condition in SLC 10A. Their preferred option would be to aggregate at the point of use, and that is to store all the detailed half-hourly consumption data in a secure environment within their business, and only aggregate it on when they request it from that secure environment. And this is really important because networks change all the time, and they like to store, if they store that aggregation, that raw data, networks can change and they can still go back to the data, look at historical data and still draw value from it to understand, even with the different configuration of their network, they can still get value from that historical consumption data. So the problem is that they do have that data disaggregated in raw form in their system. So networks are very much of the mind that they see that there needs to be a balance between data privacy and the risk and the benefits that can be obtained. So, you know, what are the risks associated with that data? Who would want to get access to it, and why? And what is the potential value of the benefits